So let's look at another example of using the formula for future value of an annuity. So here's our example. So how much money should you put into an RRSP annually, earning 7% per year, compounded annually, in order to have $1 million by the time you retire in 30 years? So what we're really looking at here is saying, what do we have to deposit in order to have a future value of $1 million? So we're going to have to readjust the formula a little bit in order to actually do this calculation. So let's do a little bit of manipulation. So I is divided on this side, so it becomes a multiply. So I multiplied by future value is equal to our deposit multiplied by 1 plus I to the n minus 1. And I'm going to take this whole bracket and bring it over as a division. So my manipulated formula is that my deposit is I times future value divided by that bracket, which is 1 plus I to the n minus 1. So let's figure out our values that we need to put into our formula. So we now have a value for future value, and we're kind of going back the other way. So $1 million is what we'd like to have in our account at the end. So we have to see what we have to start depositing. We're earning 7% per year, so our rate of interest is 0.07. It's compounded annually, so our M value is 1, and we expect to do it over 30 years. So our T value is 30, and then we can calculate our I value, which is R divided by M. So in this case, M is 1, so it ends up just being our R value. And then as well, our N value is just, our M value is 1, so it ends up just being our T value of 30, and we can substitute into our formula. So 0.07 times our future value, which we want to be $1 million, divided by 1 plus our interest, 0.07 to the exponent 30 minus 1. So again, please check in your calculator, make sure that you're following BEDMAS carefully. So you should end up getting, if you do a few steps here, 70,000 divided by 1.07 to the exponent 30 minus 1. Please make sure that you work through this denominator part, or you put brackets in the right spot as you're doing it all in one go. So either way that you do it, you should end up with a final answer of 10,586.40 to 2 decimal places. So that's what you have to invest every year to make sure that at this rate and this time frame that you get to the $1 million at the end.